All right, welcome back to statistics. So today we are going to start talking about the applications of the normal distribution. So this is going to be section 7.2, and we're just going to run through some problems. Most of our problems, like the setup parts of this, is kind of set. Okay, so if you were good in the last section, this is not going to be so bad, right? But it still won't be so bad. So if you didn't quite get it then, that's okay. You're going to be able to pick it up here. All right. So we have a normal distribution with a mean of 70, or mean of 56, okay, and a standard deviation of 20. And what they want to do, they want to say, find and interpret the mean score for x equals 74. That's what we have. Okay, so our formula for z-score, right? Z-score is x minus mu divided by sigma, okay? X minus mu divided by sigma. So our x is going to be 74 minus our mu, 56, divided by 20. All right, so we're just going to type that into the computer. Saying you have to be able to do this. Okay, 74 minus 56 equals, okay, divided by 20. Should have put 0.9 here. Okay. So what this means, okay, so we've standardized it, right? We standardized this for 74 to say that on a standard normal, this is 0.9 away. You know what? If you don't share the screen, we don't get to know anything. I'm so sorry. All right, so I wrote this down. Mean is 56, standard deviation is 20. We have our value being 74 here. Our z-score, x minus mu divided by sigma. Right? We just plug this in. X is 74, mean is 56, sigma is 20. Okay, so let's go ahead and look at that. So we're going to say 74 minus 56, hit the equal sign, divided by 20. All right, there we go. So what this is saying, right, standardized score, we are 0.9 plus 0.9 standard deviations away from the mean. That's all what z-score does. It just tells you how far away from the mean are you. Okay, so a lot of times people will be like, they'll try to figure something out, or they'll say, we're looking at heights, or we're looking at abilities, or we're looking at the weight of oranges. I mean, it doesn't matter. And you say, well, is this a good weight or a bad weight? Or am I getting more for my dollar or less for my dollar depending on this weight? And I was like, well, how far away from the mean are you? All right, the further away from the mean, usually the less likely that's going to happen. Okay, so if you're within one standard deviation of the mean, that's not really abnormal. 2 isn't really all that abnormal. But if we're talking like 3 or more, then we're saying that's unusual. Okay, but all this is doing is saying we are almost 1 standard deviation from the mean, 1 standard deviation away from the mean. Okay, so if we go back to our homework here, okay, the score was 0.9. So 74 is 0.9 standard deviations above the mean of 56. That's all it's saying. Okay, it's a little bit above average. Okay, not by much, but a little bit. Okay, so that's a good question to ask. Okay, z-scores are important. They're a very useful tool to be able to compare 2 different things from 2 different places. Okay, or multiple different things from multiple different places. Okay, now we get back into the normal distribution. Okay, we have a normal population which has a mean of 30 and a standard deviation of 6. All right, so there's number 2. So we have a mean of 30 and a standard deviation of 6. All right. What proportion is between 16 and 26? 26. And so if I was going to draw this, okay, we normally don't draw like normal distributions for like this thing, because here's 30, okay, And then we have our thing here. One standard deviation away, right? This is, here's 6 below, so 30 minus 6 is 24. This is 30 minus 6. So it's one standard deviation down. So what we're looking for, right, there's 2 standard deviations down, right? So subtract another 6. This is going to be 18. You don't have to draw this. Just, let's paint a picture of what we're doing here. So we're going from about 16, that's going to be here, okay, to 26. We're looking about here. Okay, so we're running this area in here. All right. What's the calculator going to tell us? So we're going to go to second function, distributions, down to norm CDF. All right. Now, what's our low number? Oh, I didn't want 18, I wanted 16. Okay, let's change that to a 16. Wait, where'd that 18 come from? My imagination. Okay, same thing. This is 26. Okay, 16 to 26. So our low number is going to be 16. Our high number is going to be 26. Our mean is 30, and our standard deviation is 6. All right. So that's what we're doing with that. And we'll press that in. About 25%, 24.27%. So this is going to be 0.2427. Okay, you see the rounding is going to happen here. So that's 6 to 7. All right, so 2427. All right, so let's go back here. 0.2427. Okay. What's the probability that a randomly chosen value is going to be between 25 and 35? Why did I do this? Okay, so we want to know what this is, right? 25x to 35. All right. 35. All right, so our calculator, we're going to go to second function, distribution, normal CDF, and we're going to go from 25, that's our low number, to 35, that's our high number. Our average is 30, and our standard deviation is 6. Okay, and again, a TI-84 is going to be a little nicer because it'll guide you through this. But 0.59534, this 4 is not contributing to the next number up. When we round, this is just going to drop. So 5953. Okay. 5953. We want to do norm CDF 25, 35. That's the min and the max. And then our average is 30, and our standard deviation, not that kind of 6. Okay. Standard deviation of 6. Okay. What did we come up with? We came up with 5953. All right, so that's going to be our answer here. So 0.5953. All right. Okay, great. All right, and we're just going to proceed through the chapter this way. Okay, we have 10 problems. We'll just march through them. Okay, so this is a little different. This is one of these backwards problems because they're telling us about the percentage. Okay, so we have a mean of 59, right? So our average is 59. All right, our standard deviation is 9. All right, and we are interested in like what value is going to be the 89th percentile. So what we're doing here, the way you're supposed to see this, right? Here's our 59, that doesn't really matter. Here's our standard, here's our normal distribution. All right, don't do that great, right? This area, I don't know what this number is going to be, but I know this area here, that's going to be 0.89. Okay, so what we're going to do in the calculator is we're going to go through and we're going to say we need the inverse norm. Okay, what value did I want? Well, I wanted the 89th percentile. So that'll be fine to type that in. So it's going to be 0.89. Okay. Comma. What's our mean? Our mean is 59. And our standard deviation is 9. Okay. So there we go. Our value here is 70.04, I believe. Right? Because we're going to round this 8 up into this 3. That's going to be a 4. Z-scores. This is a Z-score, remember? This was our percentage here. Our Z-score down here is always 2 decimal places. Okay, the hardest part about these problems is just keeping track of, like, where am I in the problem? Okay, this was 70.4. 70.04, sorry. Oh, ran to 1 decimal place. All right, well, I didn't need that. There we go. All right. Keep going. I think we can probably do this in one step, do you think? I think. Maybe. All right. Might be a little long, but that's okay. Okay, recent study for Centers of Disease Control and Prevention reported that the systolic blood pressure, I think that's the top one, top number, of adult women in the United States are approximately normally distributed. You kind of need this, okay, if they're going to tell us to do anything, they're kind of, because the next section that we're not going to have this. So they have to tell us approximately normally distributed. That's how come you know, could I use a normal distribution? Well, they said so, okay. And we have a mean of 80.2. No, that sounds like the bottom number. Okay, so we have our mean of 80.2. We have a standard deviation of 9.6. Okay. This is round the answers to 4 decimal places. Okay. What is the probability that a woman has a blood pressure lower than 63? So what is the probability that, notice we're using X now. If it's Z, we would have done this to it, right? We would say, what's the Z score for this? That would be 63 minus 80.2 over 9.6. We don't need this, okay? I wish we did, but we don't. So we're going to go to norm CDF, okay? And they want, what do they want? They want lower than 63. So we're going to pick a low number, okay? We're going to have our 63, that's the high number. What's our mean? Our mean is 80.2. What's our standard deviation? 9.6. So norm CDF, pick a low number relative to this average. 0 is pretty low, right? I mean, we have to center our graph at 80.2, and each step takes us 9 units. You think about, like, if you're on, on a football field, like, we're going to label the 50-yard line 80.2, and every step you take is actually going to be 9.6 yards. All right, and then we're going to see where we go. 0 is a lot of steps away from 80 if this is my step size. Okay, so we have 0, 63, 80.2, 9.6. Technically, it also allows for negative. You want to keep using negative 100, that'll still work. Okay, just be careful if we ever talk about, like, a lot of that. Okay, so we end up doing, right, second function, distribution, norm, CDF, okay. We've got 0, 63, comma, what's our average? Our average was 80.2. Okay, oh, 80.2, that's not right. 80.2, and then our step size, our standard deviation, right, is 9.6. 9.6. Okay, there we go. We're good. Enter, go. 0.03. Because this is already 2 standard, you can kind of estimate, like, we just call this 10. So how far away is 60 from 80? It's 20, so that's about 2 standard deviations. So the fact that this is a small probability, that's reasonable. Okay, so we're going to say this is 0.03659, right? 1, 2, 3, 4 decimal places. So that's going to turn this into 0.0366. All right. So we're going to have 6. No, not that much. Only 3%. 366. What am I doing today? All right, about 3%. Okay, 3% of women have blood pressures. Right? What is this? Diastolic blood pressure is less than 63. Yay. How about between 70 and 88? Okay, and these are pretty standard questions. Okay, so between 70 and 88, right? What's the probability that X is between 70 and 88? So norm CDF. This was actually an easier problem, right? Because my low number is 70, my high number is 88. My average was 80.2, and my standard deviation is 9.6. So it's about one standard deviation up, about one standard deviation down. So it should be somewhere around 70%-ish. Okay. So second function, distributions, right? Because you remember empirical rule, it says, right? 68% of the data is within one standard deviation. Okay. And then our average was 80.2, and we had 9.6. 9.6, 9.6, there it is. Yeah, 64.77. All right. So 64, 65-ish% have that. Okay, I said what, 70? So I was a bit off in the wrong direction here, but that's okay. It's still in the ballpark. Empirical rule is not meant to give you precise answers. This says, okay. Diastolic blood pressure greater than 90 is classified as hypertension. Yeah, that's definitely the bottom number. What proportion of women have hypertension? So what we want is the probability, right, that X is greater than 90. Equal 90. So I'm going to go with my norm CDF. Okay, 90 is my low number. Okay, I need a high number here. 80.2, 9.6. And I need a high number relative to this 80 with about a 10 standard deviation. Okay, so I know that 3 standard deviations gives about above and beyond. So 80 plus 30, right? 3 standard deviations would be about 110-ish. Why don't we just cover our base and say 200 here? Okay, just round. I would even say round. Just adjust to the next highest convenient number up. Okay, if you wanted to say 1,000, actually, I think I like 1,000 more. Okay, we'll just do 1,000. So somebody had a blood pressure of 1,000. Was this millimeters of mercury? Okay, everybody who's nursing right now is looking at the diastolic pressure being 1,000. Like your heart would explode. It would have exploded a long time ago. Okay, so we're going to go through. We're going to say norm CDF. Okay, so second function distribution. Norm CDF. Enter. So we're going to go with what did they want? 90 is the low number. Okay, high number. We'll go with 1,000. We could have gone with 200, probably about the same. Okay, and then we want 80.2 as our mean, and for standard deviation, 9.6. All right. Next, you give us the proportion of people who have higher blood pressure. Okay, so just as a little check, right? Standard deviation is about 10. So anything that is, right, we have 80.2 plus 10. So it's anything that's bigger than like 1 standard deviation. It's going to be, what, about 16-ish%? Okay, again, using empirical rule. All right, 15.6. This 6 is going to round this one up to a 7, so 1537. And all I did was say, well, got one standard deviation, right? There's 68% of the data is within one standard deviation. I need to know that. Okay, so 100 minus 68 gives me what, 32? And 32 divided by 2 is 16. So I know there's about 16 here, 16 there. Okay, so that's how we use empirical rule. Is like I'm kind of using it when I'm plugging things into the calculator so that I can get an estimate of like, what if I type something in wrong? Okay, will I ever know? No. But if I can give an estimate, like it's going to be about 16%, like I'm going to trust this one more because we use the calculator to get it. But it's in the ballpark of what I thought it was going to be. So I'm pretty happy. All right. Is it unusual for having a blood pressure of lower than 64? Okay, so we want, what's the probability that we have less than a 64 blood pressure? Okay, so norm CDF, right? We need a low number. Our high number is 64. Okay, so we went up to 64, negative infinity up to 64. 80.2, 9.6. I think a blood pressure at 0 is pretty low. Why don't we go with 0? Okay, so we're going to say norm CDF 0, 64, 80.2, 9.6. So anybody's taking bio 1, right? You're not doing very well if you have a blood pressure of 0, right? And your heart has stopped beating at that point. Okay, what was our? Oh, we have to type this in and get the answer. So let's plug this in and say second function distribution. Nope, not that one. That's the one I want. Okay, we're going to go from 0 up to 64. This will be all the people that are lower than 64. Okay, and then we have 80.2. Okay, and then we're going to say, oops, 80.2, comma 9.6. All right. So 0.04. Hey, we got one finally. So this is 0.045. 0.04575. This 5 is going to bring this up to an 8, so this is going to be 0.0458. Okay? 0.0458. All right. So let's go ahead and take a look. All right. There we go. So it would be unusual. It is unusual because the probability of a woman having less than 64 points, right, is 0.0458. That is less than 5%. It's not much less than 5%, but okay, but this is less than 5 pennies. So it's unusual. So it is unusual. Right? So there we go. Again, there's a lot of these problems. Okay, let's see. I think we could skip some. All right. So again, they're giving us, okay, the percentile, and they want to know what's going on with that. Okay. So what's the z-score? What is the value of the blood pressure if it's in the 40th percentile? Okay. I know generally blood pressure, having lower blood pressure is good, mostly because I'm sitting here from the point of view of the higher blood pressure. Okay. So we went norm inverse. What's the probability? 40%. Okay. We're going to have 80 points. Oh, good. They gave us nearly the same story. 80.4 in this case. Be careful. And 9.8 as opposed to 9.6. So again, be careful about that. The picture we're painting here, right, is we want this 40% here. All right. So we should get a negative z-score because it's below average, right? 40% would be below the 50%. So we're going to get a negative score here. So what are we going to have? We're going to have inverse norm. All right. Well, actually, we won't have a negative z-score. We're going to do this, but it's going to be under the average. It's going to be like 70-ish or something. Okay. So we're going to say 0.4, comma, 80.4, comma, 9.8, 9.8, and boom. Okay, 77.917. How many decimal points did they want? 2 decimal places. Okay. Normally I was going to say, well, since they gave us our information to 1 decimal place, we should go to 1 decimal place, but they said, oh, you should go to 2. So if they don't say, I'm looking at these numbers here, there's 1 decimal place. That's what I'm going to. If they gave me 4 decimal places, I go to 4. But here they said at least 2. So we have 77.92. Okay, the 7 turns this 1 into a 2. So 77.92. 0.92. Okay, and that is our, oh, we can't check the answer yet. 66 percentile. Okay, so again, inverse. Okay, we're going to go with 0.66. This is going to be a bit above average. 80.4, 9.8. Okay, so I would expect to see more than 80.4 here. Okay, not 90, it's too big. Okay, but maybe close to 90. Okay, so second function distribution, CDF, we have 0.66. You don't forget to, even though it says 66 percentile, don't forget to change it back into a decimal. Okay, 4, comma, 9.8. We should be okay. Oh, I didn't want that. I wanted the inverse function. Okay, sorry about that. So that is second function distribution. I thought I typed in inverse function. Guess I didn't. Okay, 0.66, 80.4, and 9.8. All right. So 84.44. So remember, this is giving you a z-score. Okay, or this is one of the x, sorry, this is an x value. So the units here are whatever the x values are at. In this case, it's millimeters of mercury. Okay, so 84.44. And then the first quartile. What percentile is the first quartile? 25th percentile, right? So we're going to go ahead and do norm inverse, 0.25. Here's my value for the mean. Here is my value for the standard deviation. Okay. So let's see here. We want calculator. So we're going to say second function distribution norm inverse equals 0.25. Oops, not 0.5, 0.25. Okay. 80.4, 80.4, comma, 9.8. Okay. So 73.79. All right. 73.79. Check, make sure we're good. All right. So these are usually difficult for students to do. So if you're working through this with your homework, pay attention to these. These are a little bit on the harder part, okay? And I know that. So we'll make sure we do. Yeah, you could expect one of these on a quiz. Okay. Let's see here. I think we're good. I think almost all the other problems do exactly what we've been doing. Okay. Oh, let's see. This one is good. Not as good, but decent. Okay. Average volume of beverage in a 12-ounce can be normally distributed as a mean of 12.07 and a standard deviation of 0.03. The reason why they do that, they don't want to get sued for false advertising, so they make sure it's a little bit over what they advertised And at this standard deviation, like, look, if I go down 2 standard deviations, that's going to be 2 times this, 2 times 3 is going to be 6 pennies. So even 2 standard deviations down, right, I'm still above 12.01. I'm still above the 12.0 that you promised, okay, that this company promised. So if it's more than 2 standard deviations below, then we might have some trouble, okay? But that is generally how this is set up, okay? What is the probability that a can is going to contain more than 12.09? Okay, so let's go ahead and look at that. So we want norm. We're looking for a probability. So CDF, okay. We want 12.09, okay. We want a high number. What is our mean? Our mean was 12.07. And our standard deviation was 0.03. Okay, so we need to pick a number that's relatively large compared to 12 if we have to count by 0.03s. Okay, so we're counting 3 pennies at a time. How many pennies are you going to, how many sets of 3 pennies are you going to need to get to another dollar? It's quite a few. So why don't we just call this norm CDF 12.09. I think a high number would be 15. We have to count by pennies, remember? Okay, 12.07 and 0.03. If you don't like this one and you want to choose 20, that's fine. If you don't like this and you want to choose 100, that's fine. Okay, I wouldn't choose something that was too close to these numbers though. Okay, relative to these steps. So how many pennies does it take to get from 12.07 next up to 13? And even that's quite a few. Okay, so I wouldn't even putting 13 in here, I wouldn't mind. All right. So let's go ahead and check. So we're going to say second function distribution, CDF. Okay, what's our low number? Our low number is 12.09. This is a little bit above one. It's not quite 1 standard deviation or more. So even though I'd say 16%, it's going to be a little bit bigger. Okay, 15. 12.07. 12.07. And then 0.03 for my standard deviation. Okay. So 25, 24. Okay, so my little estimate, I was way off, but my little estimate says, okay, here's 12.07. Here's my standard deviation. This would be 1210. This would be 12.10. And we want it from here up. So just 1 standard deviation up, right? That's going to be my 16% because of my empirical rule. So we have some more. Okay, that's where we got 25, and I'm okay. Oh, this is 24, 25. 20. Oh no, 25, 25. 25, 25. Okay, it's a one-hit wonder in the year 25, 25. So this is 0.2525. Okay. Probability that it will contain 12 and 12.05 ounces. Okay. By the way, for a very brief time, I didn't work in quality control, but I worked with the guy next to quality control. So if there's quality control problems, stuff like this, I will generally pick them because I like them. Okay. So 12 and 12.05. Okay, my 2 top favorite problems to pick as far as word problems go. Anything having to deal with health. Okay, a lot of students are nursing, and then anything having to do with quality control, because that's, if you're going to go into business and do quality control, they use a lot of statistics. All right, so this is 12.07. So 12.04. So we're looking at 12.05 here. And then way down here is 12. Okay. But at least we have a min and a max, so that's nice. Okay, so second function distribution, CDF. Okay, so we're going to do 12. What's my upper value? Is 12.05. All right. And then my average is going to be 12.07. And then our standard deviation was 0.003. And again, it's about 2426, 7. So that's going to round up. We have 0.2427. Okay. Oops, wrong one. Okay. 0.2427. Okay. Would have been usual to have an underfilled can. So what we want to do is set up a problem like this. We want to say, what's the probability that X is less than 12.0? Okay. So again, norm CDF. Okay. We need a low number. We want 12 to be our stopping point. Okay. Our average was 12.07 and our standard deviation was 0.03. So we need a low number relative to this one. Why don't we pick 0? Right, that's an easy number to type in. 0, 12, 12.07, 0.03. By the way, there's not a lot of, there's a wide variety of answers you could pick for this. If you are still doing this, you're not wrong. Okay, you're really not. If you pick negative 100, you're not wrong. All right, if you pick 0, you're not wrong. If you looked at this and said, okay, well, 10 standard deviations, that's 30. If I pick 11, you're not wrong. All right. So pick an easy number for you, but there's a lot of right answers you could plug in here. Okay. Now, if you pick 12, you're wrong. Okay, because 12 is too close to the upper number. Okay. You also want to be far enough away from the average and standard deviations, right? You want to be at least 3 standard deviations away. So if I do 3 standard deviations, that's like 11.09 or something, or 11.97. You want to go below that, okay? But anything below that is going to be like reasonably a correct answer, okay? You might go 4 or 5 standard deviations, but that's reasonably a correct answer. So I'm not trying to. You must do it this way. You shall guess the number that I was thinking of. Like, no, that's not it. Pick any number that's far enough away by standard deviations, and that'll be fine. Okay, I know it's too much freedom. Okay, we have 0, we have 12. Our average is 12.07. Okay, our standard deviation is 0.03. So we went from 0 to 12. That's underfilled. Okay, and our answer is 0.0098. 0.0098. Let's see the day. 981. Okay, so the 4 decimal places is 0.0098. So there is a less than, right, 0.1%. So that's about 0.1, right, 0.1%. No, it isn't. It's about 1%. Sorry, 1%. So 1% of the time, this can might be underfilled. Okay. And so, yes, it would be unusual. It's less than 5% because this is 0.0098. Okay. So very unusual for it to be underfilled. We're going to go ahead and say that's what we're going to go with. All right. And then we say okay. All right. So, the heart pressure one, blood pressure one, like that problem. Okay. Both of them, both the percentiles and the calculated percentages. And this one, I like this problem. Right? There's one with baby weights in here. Okay. Always that's good too. That's a medical question. Okay. So actually, probably wouldn't ask you this one. All right. I mean, still do it. It's easy to kind of get your hand around. But this would be like one of my least favorite problems to ask you. Okay. Heart pressure, blood pressure rather, weights of babies, good, and quality control stuff, all good. All right. So I'll leave you with that. We did it in one session. That's great. And we'll talk later. Okay.